What if I told you that the gold in your jewelry was born in a cosmic explosion brighter than an entire galaxy? This isn't the plot of a sci-fi movie, it's the reality of our universe. Supernovas, the explosive death of stars, are events of such magnitude that they momentarily outshine their host galaxies. But they do more than just put on a stellar light show. Supernovas are amazing cosmic factories, where the pressure and heat are so intense that they forge elements heavier than iron. These include precious metals like gold and platinum. Yes, that's right, the gold you wear on your finger, the platinum in your car's catalytic converter. They owe their existence to these celestial fireworks. These explosions scatter these elements across the universe, seeding new stars, planets, and even life itself. In our quest to understand, we turn to the grand spectacle of the cosmos, the supernova. From a serene star to an explosive phenomenon, the birth of a supernova is a tale of transformation. This celestial journey begins with a star, much like our own sun, albeit significantly larger. Picture a celestial body with a mass several times that of our sun, a giant in its own right, burning brightly in the infinite canvas of the cosmos. Its life, though seemingly peaceful, is a constant battle between two opposing forces: gravity, ever striving to compress the star, and the pressure from nuclear fusion, always pushing outward. For millions or even billions of years, this star has thrived in a delicate balance, a dance between these two forces. Its heart, a nuclear furnace, has been tirelessly converting hydrogen into helium, releasing vast amounts of energy and radiation in the process. This energy is what has kept gravity at bay, allowing the star to maintain its size and brilliance. But nothing lasts forever, not even the life of a star. Eventually, the star exhausts its nuclear fuel. The pressure that once held gravity in check drops dramatically. Suddenly, gravity becomes the uncontested victor, causing the star to collapse under its own immense weight. This collapse happens in a matter of seconds, a blink of an eye in the cosmic timescale. However, this collapse is not a gentle one. The star's core compresses into an ultra-dense state, while the outer layers of the star fall inward, only to be violently rebounded by the unyielding core. This rebounding force is so powerful that it sends the outer layers of the star hurtling into space at incredible speeds. This violent expulsion of matter and energy is what we call a supernova. And just like that, the once serene star is transformed. Its death throes mark the birth of a supernova, an explosion so bright and powerful it can outshine an entire galaxy. A silent star now roars with energy, its brilliance outshining galaxies. Imagine being a celestial body so bright you can outshine the combined light of all the stars in your galaxy. In the vast cosmic arena, a supernova is a spectacle like no other. It's a star, just like the ones we see twinkling in the night sky, but with a life story that is truly extraordinary. Its existence is not a quiet one, but a life lived in the limelight, a brilliant display of cosmic energy and light. The life of a supernova is defined by its brightness. When a supernova explodes, it doesn't just flicker into existence. No, it bursts forth with such intensity that it can outshine an entire galaxy. This isn't a fleeting moment either. This dazzling display can last for several weeks or even months. Imagine that, a single star holding its own against millions, billions even, of other stars for weeks on end. But it's not just about the light show. The energy a supernova emits is mind-boggling. It's like setting off 1 billion trillion nuclear bombs at once. This energy doesn't just stay put. It's flung out into space, triggering a cosmic domino effect. It's this energy that helps to forge new stars and planets, and yes, even life itself. During its peak, a supernova is so bright that it's visible even during the day. It becomes a temporary fixture in our sky, a beacon that is impossible to ignore. Its light spills over our world, a reminder of the sheer power and beauty of the universe we inhabit. But as with all things, even this radiant display must eventually fade. The supernova dims, its energy spent, its light show over. But even in this fading, there is beauty. The remnants of a supernova can linger in the sky for years, a nebula of gas and dust, painting the cosmos with swaths of color. The supernova lives not in obscurity, but in a splendid spectacle of cosmic light. All things must end, even stars. But the death of a supernova is not a quiet affair. The final act of a supernova is a performance of cosmic proportions. As the supernova reaches the end of its life, it undergoes a catastrophic explosion, expelling most of its mass into the infinite vastness of space. This grand finale is not a silent departure but a riotous explosion that outshines an entire galaxy for a brief, unforgettable moment. In the aftermath of this cataclysmic event, a nebula is born. A nebula, in essence, is an interstellar nursery, a cosmic cloud of dust, hydrogen, helium, and other ionized gases, all remnants of the deceased supernova. This nebula, glowing with the echo of the supernova's death throes, is a spectacle of color and light. It's within these celestial cradles that new stars are formed, a testament to the circle of stellar life. And what of the heart of the supernova, its core? Well, that follows a different fate. The once fierce heart of the star, now a mere remnant, becomes incredibly dense. If the core is of a certain mass, it shrinks down to form a neutron star. These neutron stars are incredibly small and incredibly dense, with a teaspoon of neutron star material weighing as much as a mountain. They spin rapidly, sending out beams of radiation that sweep across the cosmos like a lighthouse. But if the core of the supernova is massive enough, it doesn't stop at a neutron star. Instead, it continues to shrink, collapsing under the weight of its own gravity. It shrinks and shrinks until it forms a point of infinite density, a point from which not even light can escape. And so a black hole is born. These enigmatic entities are the ultimate end for the most massive of stars, a profound punctuation to a stellar life. From a dazzling light to a nebula or a black hole, the supernova's end is as dramatic as its life. The power of a supernova is difficult to grasp. It's a cosmic explosion of a magnitude we can hardly comprehend. Now let's dive into the astonishing power of supernovas, these celestial fireworks that make our universe a dramatic spectacle. First, let's talk about brightness. A single supernova can outshine an entire galaxy. To put it in perspective, that's billions of stars collectively outshone by a solitary stellar explosion. This celestial event can be so bright that it's visible in the daytime sky, like a second sun, a testament to its staggering luminosity. Next, consider the energy they release. The total energy a supernova expels equates to the amount the sun will emit over its entire 10 billion-year lifespan. Yes, you heard that right. A single stellar explosion releases as much energy as our own sun will produce in its entire existence. This energy isn't just light and heat. It's a cocktail of cosmic rays, neutrinos, and other particles that whiz through the universe at nearly the speed of light. But the power of supernovas isn't just in their brightness or energy. It's also about creation. The explosion of a supernova is so intense that it triggers the formation of new stars. In the heart of these cosmic fireworks, elements heavier than iron are forged. These materials, scattered across the cosmos by the explosion, become the building blocks for new stars and planets. Supernovas are quite literally star makers. To add another layer of amazement, many of the elements that make up our own bodies were once part of a supernova explosion. We are, in a very real sense, made of stardust. In their death, supernovas breathe life into the universe, birthing new stars and elements. They are the cosmic phoenixes, dying in a blaze of glory to give rise to new celestial bodies. The power of supernovas, then, is not just in their destruction, but also in their creation. They remind us that even in the face of death, there is always the promise of new life. We are more connected to these cosmic phenomena than you might think. Supernovas, the spectacularly violent deaths of stars, are not just distant, awe-inspiring spectacles. They are, in fact, integral to our very existence. As these stars explode, they create and scatter elements across the universe. Many of these elements are familiar to us: oxygen, carbon, iron, the very building blocks of life as we know it. In the fiery crucibles of these dying stars, elements are forged. The process is known as nucleosynthesis. Inside the supernova, temperatures reach billions of degrees, hot enough to create these heavier elements. When the star finally explodes, these elements are scattered across the universe, seeding the cosmos with the potential for new stars, new planets, and yes, even new life. This process is awe-inspiring to contemplate. Every atom in our bodies, the air we breathe, the ground beneath our feet, was once part of a star that exploded in a brilliant supernova. This leads to the beautiful and humbling realization that we are, quite literally, made of star stuff. This phrase, first coined by the great astronomer Carl Sagan, encapsulates the profound connection between us and the cosmos. We are the children of stars. The atoms that make up our bodies have journeyed across the universe, formed in the hearts of exploding stars, to become part of us. We breathe and live thanks to the oxygen that was once created in a supernova. We stand firm on this earth thanks to the iron in its core, iron that was once scattered across space by a dying star. So the next time you look up at the night sky, remember this: you are looking at your ancestors. Those distant points of light are not just stars, they are the forges where life's ingredients were made. In the grand cosmic ballet, we and supernovas are entwined in a dance of life and death. Supernovas continue to captivate us, their mysteries as compelling as their light. In the grand tapestry of the cosmos, supernovas are some of the most dramatic events we can witness. These cosmic powerhouses, with their explosive deaths and radiant afterlives, have been a subject of fascination for centuries. And yet, despite our technological advances and increased understanding, supernovas still hold secrets that elude our grasp. We've journeyed far in our understanding of these celestial phenomena. We've unraveled their birth, life, and death. We've seen how they forge the heavy elements that make up our world and ourselves. We've witnessed the power they unleash, outshining entire galaxies for a fleeting moment in cosmic time. Yet there's still so much we don't know. Each observation, each discovery seems to raise more questions than it answers. What triggers the final detonation? What happens to the core that's left behind? How do supernovas affect the galaxies they inhabit? The enduring mystery of supernovas is what drives us to explore further. Scientists all over the world are tirelessly working, using the most sophisticated telescopes and technologies to peer into the heart of these cosmic wonders. They're studying the light they emit, the particles they spew out, the shock waves they send rippling through space. And it's not just about satisfying our curiosity. The answers could have profound implications. They could help us understand the fundamental laws of physics, the evolution of galaxies, even the fate of the universe itself. So we continue our cosmic quest, each discovery a step closer to unveiling the secrets of these cosmic cataclysms. We've come a long way, but the journey is far from over. The story of supernovas is still being written, and with every new chapter, we get a little closer to understanding the grand narrative of the cosmos. As we continue to gaze upon the cosmos, we remain entranced by the tale of supernovas, their birth, life, and death. From a cosmic spectacle to the creator of elements, the story of supernovas is a testament to the wonders of our universe. As we journeyed through the life of a supernova today, we have seen the birth, life, and death of these celestial marvels. We started from the unanswered question of what supernovas truly are, and we have arrived at a place of greater understanding, though much still remains to be discovered. The birth of a supernova, a process of transformation and explosive energy, is nothing short of stellar alchemy. The star, once a stable entity, undergoes a dramatic transformation that leads to an explosion of such magnitude that it can outshine an entire galaxy. In its life, the supernova continues to burn brightly, radiating energy across the cosmos. It lights up the celestial stage, a temporary yet unforgettable spectacle. Its death, though seemingly destructive, gives rise to creation. The supernova's demise seeds the universe with elements, the building blocks of life as we know it. We then delved into the power of supernovas, the immense energy they release, and how they shape the universe. The effects of these cosmic fireworks are not confined to their immediate vicinity. They reach far and wide, influencing galaxies and potentially even life on distant planets. In our journey, we also explored the connection between us and these distant celestial events. Elements that make up our bodies and the world around us owe their existence to the explosive death of these stars. We are, in a sense, made of stardust. The enduring mystery of supernovas speaks volumes about the infinite wonders of the universe. With every secret we unravel, new questions emerge, keeping our curiosity piqued and our thirst for knowledge unquenched. Remember to keep asking questions, keep exploring, and keep looking up. The universe is a vast, intricate tapestry, and we have only begun to trace its threads. As we unravel the secrets of these cosmic fireworks, we come one step closer to understanding our place in the grand scheme of the universe.